Hello, everybody. In this video, we are going to solve the question 67 about delta epsilon, definition of the limit. That's what we are going to figure out. That's what we are going to work it out. And we suppose this is the basically the definition of it in this example. We try to understand what is the limit means. This is the case when x goes to the infinity. Later on, we were going to work on when x goes to a number. So we assume that for every epsilon in between 0 and 1, it is a small epsilon. We sometimes, instead of this, we sometimes say for every epsilon bigger than 0. This would be enough to say it, but we mean by epsilon is a small number. It's always a small number. We always think that the epsilon is close to the 0. Even though we write only epsilon is greater than 0, by giving the name of the epsilon, it will be a small number. Now, our aim is to find m epsilon. Some of the people are using a delta epsilon. Sometimes we can use a delta epsilon. Our aim is to find out m epsilon. M epsilon and identity, a kind of a function depending on an epsilon, satisfying this condition. If x bigger than m epsilon, then fx minus L, this is an absolute value here, it should be smaller than epsilon. This is the definition of delta epsilon definition of the limit. And we denote this with limit x goes to the infinity, x, because x can be larger and larger and larger, and fx approaches to L. What that means? What that means is that we have any function like this, any function, we don't care. We are taking an L, we have L is the function approaches to L when x goes to the infinity. Well, this is an x-line. X-line gets larger and larger and larger. Then we want the function gets approaching to the number L. So we are focusing on very small interval of L. So you have L here. We are looking at L minus 1, L minus epsilon, L plus epsilon. So this is a little rectangular band. And when we get the idea is that we are getting the epsilon and smaller and smaller and smaller, such that we are getting to the line of L, approaching the line of L by taking the epsilon smaller and smaller and smaller. Meanwhile, we are looking at the x values and larger and larger and larger. So when the x gets larger, goes to the infinity, you want your function to approach something. And that something here is just L. So in this definition, you can take this m epsilon somewhere, anywhere, right? If you have epsilon is in this rectangular band, it is perfectly okay to take the m epsilon as from here or from here or anything from there, because it should be inside this rectangular band. But it is not correct, for example, to take m epsilon here, because this m epsilon, as we see, the function is above the rectangular band. So it is impossible if we cannot take this m epsilon. There exists an epsilon, and after that, for each m epsilon, we can take it, and that this approach will work. Okay, so that's the definition. That's the logic. That is the definition of a limit. And it is beautiful. And the idea is that when epsilon getting smaller and smaller, when epsilon is getting higher and higher, then we have the function is getting closer to the L. So in an example, how we can use that, how we can prove it. Use this to prove that limit x goes to the infinity, x squared minus 2x plus 3, x squared minus 2x plus 2 is equal to 1. first thing to take an epsilon, any number between 0 and 1, or epsilon bigger than 0, which means a small epsilon. And now our aim is to find out an m epsilon. And this is what we, so this one here, what I'm writing here, I'm not assuming that I know this, but I'm looking at what will happen if this happens, then this happens. So I would like to know what I want to find it out, what kind of things I want to find it out. This is why I wrote it here. So, okay, if fx minus 1 smaller than 1, it means that when we put this fx here, of course, we will make the denominators are the same and simplify. Then we have this 1 over x squared minus 2x plus 2 is smaller than x. So this is the kind of things that I would like to work it on. I want this kind of things smaller than epsilon. Now, I'm not assuming this in this here. I'm just checking it out. How can I approach this? So I'm doing this in a corner, basically. Or I'm saying, if this happens, then this happens. So I'm not saying this happened. Then now we are taking the x bigger than m epsilon. This is our assumption. We don't know m epsilon. Our aim is to find out an m epsilon. So this is an inequality. So I would like to play with this inequality and get an expression looks like this. So if I take the x squared minus 2x plus 2 on this side will be bigger. So I'm making basically bigger. So x, this quantity here is bigger than x. It is clear because I'm taking the square and then a minus 2x plus 2 will be bigger than x. Okay, you can get as bigger as possible to that side. And I'm switching off, which means that if this is a general knowledge, I'm pretty sure you know it, but let me repeat. A is smaller than B, then 1 over A is bigger than 1 over B. When you're flipping over those numbers, then this direction will change. This is an important bit, don't forget that. So if you have this smaller equality here, this one will be bigger than equal to. If you have bigger than equal to here, then you will have the smaller than equal to. So, okay, I am flipping this quantity, this inequality, flipping over, and then I can take this absolute value, no problem. Then I found this kind of expression. So I'm looking at this expression, and I would like to say epsilon is equal to 1 over epsilon, right? I want this one is equal to that one. This is exactly what it is. If I say epsilon is over 1 over epsilon, which means that m epsilon is 1 over epsilon, I found my m epsilon, then it is done. It is all I need in this question. Our aim is to find out m epsilon, which depends on epsilon, satisfying this condition and satisfying this condition. So it is a bit tricky. Start from there, but be careful. You're not doing it. You're saying, if this happens, then what happens? Let's see. And then you're looking at the result that you got and then figuring out what kind of things that you would like to get. Okay, I think this is clear. Let's do another example, question 68. Here we have this function. We would like to find out the limit, and we would like to prove that with the epsilon delta definition of the limit. And it's asked that if m is equal to epsilon squared, this is the correct answer. Let's check it out. Limit x goes to the infinity, 1 over root x. X goes to the infinity, so this will be the infinitely large. 1 over infinitely large means it's approaching to 0. So the limit is 0 for each epsilon in 0, 1, fx minus 0, this is L. L is equal to 0 in this case, smaller than epsilon. So fx is 1 over 1 plus root x. So this is what we have. If this happens, this is what we have. I am not saying that, I'm not saying anything in that moment. Now consider x bigger than m epsilon. 1 plus x, I'm adding the, I'm taking the square root on both sides and then adding 1 on both sides, and nothing will change. But I would like to flip over this quantity, and then this direction of the bigger sign will be the smaller sign. So I have 1 over root x and 1 over root mx. Then we can take the square absolute value. Then this value should be equal to epsilon. So we choose m epsilon such that, right, that we choose m epsilon such that we choose m epsilon such that epsilon is equal to 1 plus square root of m epsilon. And then we have epsilon is 1 over epsilon minus 1 squared. We found an epsilon. It means that what we found so far, for each epsilon between 0 and 1, there exists an m epsilon. We found that one, such that this condition satisfied. And here, when I'm saying, I'm not saying this is what holds. Basically, we are looking at this holds, and under this condition, this holds. Okay, good. And the question, another part of the question says that if m is equal to 1 over epsilon squared, is this correct? Well, our m epsilon is basically 1 minus epsilon over epsilon squared. 1 minus epsilon squared, since epsilon is between 0 and 1, this is smaller than 1. So we flip or smaller than 1. So this is 1 over epsilon squared. But when you are multiplying something very smaller than 1 with any number, that will be smaller. So this part will be smaller. Right? This part is bigger and this part is smaller. So 1 over epsilon squared is a bigger number than what we found. And we know that from the definition, we can choose, we found that m epsilon here, right? And then any m epsilon that we choose after that, all of them will be correct. So by using that logic, that idea, we can say that 1 over epsilon squared is the correct answer as well. But also we can just prove directly, as we've done in previously, looking at x bigger than m, and then take the square root. This part will be larger, so 1 plus root x bigger than root m. And then flip over, we have, this is the quantity we want. We can make absolute value of this. Then we say 1 over root m is equal to epsilon. Then m will be 1 over epsilon squared. We will find that m as 1 over m squared. So it will perfectly fine. Either we will use these, or we will just look at our answer. If we can say this is bigger than 1 over epsilon squared, that will work. Okay, I think that's enough for this question. Thank you very much.